Hello. Let's discuss the problems of the starters 140, which was held today on CodeChef. Due to late start and problem in network connectivity, I was able to solve only the first four problems. So I will be discussing only them. So let's go for the first one. So in this problem, we have been given an array of size n, and we need to construct another array b, such that the sum of those arrays, like for some index I, if we sum up ai and bi, then the produced array c should be a permutation of n integers, right? So, like if you see in this example, n is given as 5, and the numbers, these are the a array. So you need to find the array b in such a way that for all I, ai plus bi will form a different array c, and that should be a permutation of 5, right? So what is meant by permutation is like all the numbers from 1 till n should be present in that, and every number should appear only once. Right. So what we can do here, like if we see 1, 2, 3 is already present, so we can mark 0, 0, 0 for our array B, so that the sum will also be 1, 2, 3 in the final C array. And for these two numbers, like what are missing, 4 and 5. So 4 is already there, so this we can also mark as 0. And for this, if we mark b of I as 4, then it will be 4 plus 1, 5, right? So 1, 2, 3, 4, 5, all the numbers would be present in the array C. So that's a perfect permutation of n equals to 5. So that's why the resulting array of B is 0, 4, 0, here. So likewise, if you try to do this, so what we observe here, like we can't produce one here, right? Because you have to add. You can't subtract any number, so you can't make any number lesser. You can only make it greater than whatever it was previously. So the lowest number here is 2, so you can't make one out of this by adding anything into it, like any non-negative integer. So it is not possible to make a permutation of n equals to 5 for this array. So by this observation, you can see, like what we will be trying to do in the code. If I show you, like I took a visited array and the original array A, and in that I marked all those numbers which are already present in the array. And let's say for mx, I took a variable mx which denotes the current number we are trying to find in that array. And while that mx is less than equals to n, what we are doing, so if it is already visited, then decrease it, like it has been used once, right? Like here 1 is present twice in this array. So when we visit this one, so it has been marked for the use of 1, right? And this one will be used to make 5. So in that case, we have on when we are like trying to make 5, then this one will not be getting count, right? So that's why whenever we are visiting any mx, if it is already present in the array, then we will decrease its count by 1. So that's why this visited of mx minus minus. Or else, if it is all not already present in the array, like for n equals to 5, if you see this array, so if you try to find 5, it is not present, then it will come to this one. And we mark a flag at 0, and for every number. And since we can only add on to some number, so we will visit all the numbers that are lesser than mx and greater than 0. And we try to find if it is present in the array, then we will mark it, then we will decrease its frequency, and we will increase that number to mx, right? We can increase, like For n equals to like for mx equals to 5, if you go to this one, then you can decrease the, then this I will be iterating from 4 till 1. So when you come to 1, so instead of 1 will be 1, because this one has already been removed. So like that you can do. And if you find any number which is lesser than that and still present in the array, so you just mark the flag as 1 and break there only. So if you have found, then you will be breaking. Like if you haven't found, for this one, if mx equals to 1, then you can't make any number 1 that are already present in that. So we will just break out of it. And if you have found that, then you will continue for the higher values. So similarly, if you find if you have found a way to build each element from 1 till n, so your mx will be n plus 1, right? So that's what we are checking at the last. Like if the mx is greater than n, just print yes or else print no. Let's go to the second one. So here it is like you are given two arrays of size n and a separate value m. And what you need to do, like you need to pick a candy box and a chocolate box. Candy boxes are a arrays, and uh, chocolate boxes are in b array, right? So you need to pick one box from any of the arrays from each one of them. And you need to pick in such a way like the sum should be perfectly divisible by m, like you have to evenly distribute, right? You will then mix and select candies and chocolates and distribute the combined sweets equally among the m children, so that sum should be perfectly divisible by m. So that's what we are counting here. Like if you see here this 5, so you can pick this 3 and this 12, which gives us a sum of 15, which is perfectly divisible by this 5, right? So likewise you can check. So how I did it was by taking modulo. Like you can take every number modulo m, such that you can keep track of how many modulo 2s are already present in the array 1 and how many modulo 3s are present, like that. So up till 0 till m minus 1, you will get like how many, what is the frequency of that count, right? So initially I have taken the vectors input and marked like for what frequency it is appearing in the array. So in the first map, I am taking care of the first array, and in the second map, for the candies. So initialize your answer as 0, and then you try to make pairs. Like how many pairs can be made by taking that a of I, right? So first you take the modulo by m and mark it as num, and if that num is 0, like for this 5, this 10 modulo 5 will be 0, right? So you need to find another element inside this b array such that its modulo is also 0, right? Then only they can sum up to a number that is divisible by 5, right? Like this 10 and 15 gives 25, which is divisible by 5. So similarly 8 modulo 5 is 3. So you need to find 5 minus 3, that is 2. Like any number, like how many numbers are there in this array which gives uh, value 2 when modulo by 5, right? So that's what we are counting here. If the num is already 0, like the modulo of the element in the first array is already 0, then we need to find like how many numbers it can be paired in the second array with, right? So it will be adding like what is the frequency of modulo 0 in the second array. And similarly, like you need to find, like if some num is there, then you need to find the frequency of m minus num in the second array, right? And you simply add it to the answer and print it. So that's all about the second one. Let's go to the third one, which was pretty interesting. Like you need to find the maximum integer k such that the permutation can be split into exactly k subarrays where each subarray has the same sum. So, like you are given an integer n, and you have to create a permutation of length n, like every number from 1 till n, and appearing once only in the array. So, you have to find the maximum integer. You need to generate that permutation, which has, like, let's say a sum n. Let's say some x will be there, so that x should be appearing maximum number of times, like if some subarray, and all the subarrays should have that sum only, right? Like the number of subarrays having that sum should be maximum. So you have to find, you have to set an integer k like that, right? So for n equals to 1 and 2, it will be like that only, like you can't change this, this with this whole subarray, right? And for other numbers, if we take like 3, so let's say if it's an odd number, let's say 7. So how we can design, like you see here, if I write all the numbers, that permutation. So these are the all numbers that will be present in that permutation of n equals to 7, right? So if we take up two elements, then that will form maximum number of pairs, right? Or else, what is the other option? Like for making maximum number of subarrays having equal sum, we can, the first option is to take one element. So if we take one element, the all the subarrays will definitely be not having the similar sums. So can we take subarray of two elements? Can we design our permutation such that we take two elements and all the subarrays, and we have a sum which is present in maximum number of subarrays? So let's try to find out. So if our n is odd, like in this case it is 7, so you see this pattern: 1 plus 6 is also 7, 2 plus 5 is also 7, and 3 plus 4 is also 7, and this is 7 alone, right? So we have found four subarrays. If we write it like this: 7, and after that 1 and 6, 2 and 5 are paired, 3 and 4 are paired, right? So we have found four subarrays. Like first one will be this, second, third, and fourth, right? So all these four subarrays have a sum 7, right? So this is the case for odd. Like if the n is odd, what will be the even case? Like if you take n equals to 6, so what all we have: 1, 2, 3, 4, 5, and 6, right? So if the number is even, then we can just pair up the first and the last, the second and the second last, like that, right? Because this 1 plus 6 is 7, 2 plus 5 is 7, and again this 3 and 4 is 7, right? So this gives us, like if we write it like 1 and 6, and after that 2 and 5, and 3 and 4. So for n equals to 6, this array will be having three subarrays which are having sum equals to 7, right? So for length 2 of the subarrays, we have a solution. So this would be the best if we try to minimize the length of the subarrays and maximize the number of subarrays. So that's what is being asked in the question. So that's what I have done in the code. If I try to show you, So for n equals to 1 and 2, I have just outputted whatever was there in the there in the example. And if the n is odd, you just print 7 first, and then you take two pointers I and j, and increase the first one and decrease the last one, and just print them. So it will be getting printed into this format, right? So 7, then 1 and 6, 2 and 5, 3 and 4, like that, right? So, and if n is even, you just print the first and the last, the second and the second last, like that, right? So this was all about the third one. Now the last one, which I have solved in the contest. Yeah. So this problem is about a given tree with n vertices, and each vertex is assigned a value which is given in the problem, and what you need to do in a single operation, you need to find uh, a node which have an odd degree. What is the degree? Like a degree of a vertex is called like how many nodes, how many other nodes are connected to that particular node. If it is not forming a cycle, then how many edges are from that particular node is called the degree of that node, right? Like how many edges are connected to that node. So in a single operation, you can pick any vertex which has an odd degree, and you add the value of that node to your answer, and you can remove that particular node and all the edges that are connected to that node, right? So doing that operation, maximize the you need to maximize your answer, like the scores of the nodes that you have removed. So you need to maximize that score, right? So if you carefully observe this one, so let's go through this example, 1 2 and 2 3. So the tree given to us is like 1 2 and 3, right? So let's give them some values x, y and z. So what if I say you that x is greater than y and y is greater than z? Then what you would be doing, like if you need to maximize your score, right? So you will try to take the maximum scores, right? So if you take this one, it has an odd degree, right? Because it is connected to only one other node. It has only one outgoing or incoming edge, because it's a bidirectional graph. So it has only one edge connected to it, so its degree is odd. So we can pick up that x. We can similarly, and we have to remove this one, right? And in the second operation, what we will be doing, we will be taking this y value, and not the z value, because we need to maximize our score. So since z is less than y, so we will be picking up this 2, right? And after that, this 3 will be, and this edge will be also deleted, right? Let me delete the edges also. Unfortunately, my cursor is not working properly. So at the last, only one single vertex will be remaining, right? So this vertex will not be getting chosen, right? So its value will not be getting added to the answer. So what we observe, like uh, if we leave the node with the minimum value, then we can get our answer maximized, right? So that's what I am trying to find in my code, like which node is having the minimum value, and we mark it as root. Okay, so if I show you my solution, there the root then all the nodes we will be considering like the children of it, right? So what we try to do is like not to include that root node into our answer, and except that all the nodes we would be trying to include it in the answer, right? So in that way we can remove that like that node, that root node which is having the minimum value from the answer. So that's what I am trying to do. So for that, if you are aware of the topological sorting, so that's what I am trying to do. Like I am first trying to choose the outermost vector, outermost node, which is having only degree of 1. So as you can see, all these nodes are having degree of 1. This node is having degree of like 1 2 3, right? And this is having degree of 2. So remember, like I am this solution is totally based on topological sorting, which is based on degree of the node and not on the value. So for the value, I have taken the pre-calculation and marked that node as the root, which has the minimum value. Trying to do is like I have already calculated the degree of all the nodes and taken a Q like the classical topological sorting solution, and we have marked the root as the whichever node is having the minimum value as our root, and inside that if the if whatever node is there and its degree is 1, then we are pushing it inside our queue so as to prune the tree in the uh, in decreasing order of like whatever their degrees are there. So this is the classical topological sorting solution. So inside that, as you can see, like I am decreasing the value of degree and marking it as visited, and whichever node we are traversing right now, we are pushing it inside our answer vector, right? So in this way you can get what should be the order of your solution, so that we are putting inside our answer vector, and at last we are printing the size and the order of that solution.